Hey everyone, now continuing with the second example of our graphs and transformations, we'll be looking at an actual graph, but we'll still stick with the idea of y equals to fx, and therefore we'll then be applying the AMMA route. And it's gonna be a bit different, so do pay attention to how we do it, alright? Now we have x squared over 4 minus x. We want to transform it to x minus 1 whole thing square over 10 minus 2x. And well, let's look at what we need to do, alright? So what we have x minus 1, so this is clearly a transformation, right? So we go correspondingly, x squared becomes x minus 1 whole thing square. It's a translation, so therefore we have the first A. But then at the bottom, you notice that, hey, we have 2x, but we only have x down here. So it's two different coefficients. So is it even scaling? Because if you're going to scale, we're going to have x, 2x on top and 2x below, but we only have 1x on top and 2x below. Therefore, there is unlikely to be scaling for our x. Alright? So if there's no scaling for our x, what else can we do to achieve minus 2x? Or rather, how do you achieve 2x at the bottom? Because this is already 4 minus x. So why not we try the translation first, right? Because we are going to do translation first anyway, so let's do that first. So we do the translation, which is basically, for the first step, will be translate 1 unit in the positive x direction, right? Because it's minus 1, so it's in positive x direction. You need more x to get the same numerator. Now, your x squared over 4 minus x will then become x minus 1 whole thing square over 4. Now, be careful with your sign. You get 4 minus bracket x minus 1. Therefore, you have at the end, in the denominator, 5 minus x. Okay, now, what do you notice about 5 minus x and 10 minus 2x, right? So we settled the numerator. Now we need to settle the denominator. You notice that in the denominator is 10 minus 2x. It is twice of the 5 minus x we have here. Alright, so we are just lacking times 2 and times 2. Alright, so we need to times 2 the denominator, which means we need to multiply by half. Alright, so if you're going to multiply the whole function by half, that means it is a scaling that is parallel to the y-axis now, because our y values are now halved and we have scale factor of half. This will then get us the final curve from x minus 1 whole thing square over 5 minus x. It becomes y equals to x minus 1 whole thing square times half, which means our denominator 5 minus x times 2, 10 minus 2x. Alright, so the idea is this. Alright, you see different x coefficients, it is slightly not scaling for the x variable. It is possible, but it means that you might need to scale your translation first and then perform some other weird things as well. You end up doing more transformations than needed. Whereas if you're to just follow in, like, just ignore the scaling for our x, instead try to scale y instead because it's y equals to fx, then you had a better chance. Alright, so this is a second example of our combination questions, and we'll move on to another type of question.